Hey everyone, welcome to my channel, where we dive into the most thrilling scientific breakthroughs. Today we're tackling a topic that captivates us all, the possibility of living forever. In this video, I'll share 3 scientific facts about immortality that will blow your mind. These aren't fantasies, but real research reshaping how we view life. We'll explore each discovery in depth with stories, experiments, and future prospects. Ready? Let's dive in. The first fact centers on telomeres, tiny caps at the ends of chromosomes that protect DNA, like plastic tips on shoelaces. Without them, DNA would fray with each cell division, causing chaos in the body. Every time a cell divides, telomeres shorten, eventually halting cell renewal and leading to a state of senescence, cellular old age. This was discovered in 1961 by American biologist Leonard Hayflick at the Wistar Institute in Philadelphia. Cultivating human fibroblasts, skin cells, he found they divide only 50 to 70 times before retiring, triggering inflammation and age-related diseases like arthritis or cancer. His Hayflick limit became the cornerstone of aging biology. But in 1978, studying yeast and tetrahymena, single-celled organisms, Australian scientist Elizabeth Blackburn began unraveling the mystery. In 1984, at the University of California, she, along with Carol Greider and Jack Szostak, discovered telomeres, an enzyme that adds new segments, TTAGGG sequences in humans, to telomeres, enabling cells to divide indefinitely while staying youthful. They synthesized telomeric DNA in vitro, proving its role, and earned the 2009 Nobel Prize in Physiology or Medicine. Blackburn, born in 1948 in Tasmania, showed telomeres is active in stem cells, embryos, and cancer cells, granting them immortality, but is suppressed in normal cells to prevent uncontrolled growth. Nature offers examples. The hydra, a tiny freshwater polyp, doesn't age due to constant stem cell regeneration powered by active telomeres. Even more astonishing is the Turritopsis dohrnii jellyfish, dubbed immortal. In the 1990s, Italian biologists Ferruccio Bozzetti and Maria Pia Miglietta at the University of Lecce found that under stress, starvation, injury, cold, it reverts to a juvenile polyp stage through transdifferentiation, where mature cells reprogram into stem cells. In 2025, their team identified the FOXO3 gene as a key regulator, now tested in regenerative medicine, like heart tissue repair. Blackburn's 2010 studies involving thousands of people showed lifestyle impacts telomeres. Regular exercise, 30 minutes daily, 5 days a week. Meditation, e.g., 15-minute mindfulness. And antioxidant-rich diets slow telomere shortening by 10 to 15%, while stress, smoking, or obesity accelerate it by 20 to 30%. In her 2017 book, The Telomere Effect, co-authored with Alyssa Epple, Blackburn notes that mothers under chronic stress have telomeres equivalent to 10 years of extra aging. In 2025, clinical trials at Stanford, the University of Tokyo, and the Pasteur Institute test telomerase activating drugs like TA65 from astragalus and synthetic molecules. Phase 2 trials have extended cell activity by 25% in patients with telomere disorders, like bone marrow dysfunction. Google-backed Calico invests billions. Their tests on mice and dogs show telomerase activation slows organ aging, cutting heart attack risk by 15%. Unity Biotechnology develops senolytics, drugs clearing senescent cells, combined with telomerase, boosting mouse lifespans by 30%. Mastering telomerase could let cells renew indefinitely, ushering in an era of biological youth. But it raises questions. Can society handle overpopulation or unequal access to such tech? This isn't just science, it's a revolution in time, health, and human potential. The second fact takes us into quantum physics and the nature of consciousness, where immortality lies not in the body but the mind. In the 1980s, British physicist and mathematician Roger Penrose, studying gravity and quanta, questioned why classical neuroscience couldn't explain consciousness. In 1994, with anesthesiologist Stuart Hameroff from the University of Arizona, he proposed the ORC-OR, orchestrated objective reduction theory. They argue consciousness stems not from neural electricity, but from quantum computations in microtubules, 25 nanometer protein structures inside brain cells. Made of tubulin, microtubules act as quantum processors, existing in superposition, multiple states, before collapsing via gravity's influence, creating moments of awareness. The theory explains why anesthesia shuts off consciousness. Gases disrupt quantum coherence in microtubules. From 2014 to 2017, Hameroff's anesthesia experiments using spectroscopy showed microtubules retain information even when the brain is off, like under anesthesia. In 2025, studies on IBM and Google quantum computers confirm microtubules process data at a subatomic level, like qubits, solving tasks classical computers can't, such as complex pattern recognition. This suggests consciousness is a quantum entity tied to a universal field, perhaps Planck-scale space, and could persist beyond the body, transitioning to another state, like a wave in a cosmic ocean. Penrose, a 2020 Nobel laureate for black hole research, links this to gravity in his 1989 book, The Emperor's New Mind, and 2025 updates. Wave function collapse is when the universe chooses reality, with consciousness as part of that process. This aligns with biocentrism by American biologist Robert Lanza, head of Advanced Cell Technology. In his 2009 Biocentrism, How Life and Consciousness Are the Keys to Understanding the Universe, he argues consciousness creates reality, citing the quantum double-slit experiment. Electrons act as waves or particles based on observation. His 2001 human embryo, cloning for stem cell therapy, showed life's ability to form anew. In his 2020 The Grand Biocentric Design, Lanza suggests consciousness persists in parallel realities, like a multiverse. In 2025, he collaborates with physicists to model quantum processes, linking consciousness to the multiverse. If correct, our self is an eternal information stream, transforming without vanishing. This prompts a question. If consciousness is eternal, what defines our individuality? The third fact shifts to technologies promising digital eternity. American futurist Ray Kurzweil, ex-Google engineer, predicts by the 2030s we'll upload consciousness to the cloud. In his 2005 The Singularity is Near, he describes a singularity where AI and biotech merge with human minds. In 2025, Elon Musk's Neuralink tests brain-computer interfaces. Early patients send signals to digital systems. In 2024, paralyzed individuals controlled cursors with thought, transmitting data to the cloud. This is a step toward digital avatars, eternal personality copies. In 1988, robotics expert Hans Moravec, in Mind Children, proposed scanning every neuron and synapse to create a digital human replica. In 2025, the NIH-funded Human Connectomy Project maps the brain's billions of connections, building 3D neural models. Japan's Nectomy reports progress in preserving neural structures chemically, though it demands massive computing power. US and Chinese startups like Kernel and Neuralink develop AI to model consciousness from brain scans. In 2024, Kernel unveiled a device recording neural activity and turning it into digital behavioral models, replicating responses to stimuli. Kurzweil estimates that in 10 to 15 years, computing power will hit levels to create digital worlds where personalities live without bodies. In 2025, supercomputers reached 10 to the 16th power operations per second, rivaling the brain's 10 to the 15th power neural operations. AI models, like those from XAI, mimic cognition, memory, emotions, decision-making. This suggests consciousness is information transferable to code. If so, we could join a global digital network, like characters in an endless game. But it raises questions. Will a digital self retain our uniqueness? How will society change if millions become virtual beings? These technologies don't just promise eternity, they redefine what it means to be human. These three facts, telomeres, quantum consciousness, and digital eternity, show immortality isn't a myth but a scientific horizon. Telomeres restores cellular youth, quantum microtubules tie consciousness to the cosmos, and tech offers virtual existence. This opens vistas, life without limits, where we create, love, and explore infinitely. But are we ready for such a future? What does it mean to live forever, as humans, energy, or code? Thanks, friends, for watching. If this video sparked your curiosity, hit the like button, subscribe, and share your thoughts in the comments. Do you believe in eternal life? See you next time. Keep exploring the infinite.